मित्रांनो, just we discussed about the chapter interference. Now in this lecture, as we discussed, we will see some numericals, some problems based on chapter interference. First problem, see, in Newton's rings experiment, the diameter of the 15th ring was found to be 0.59 centimeter and that of the 5th ring was 0.336 centimeter. If the radius of the plano-convex lens is 100 centimeter, calculate the wavelength of light used. This problem was asked in October-November 18. Oftenly in the university exam, this type of problems they are asking. We will write the given things here. The diameter of 15th ring, that is a D15th, is given 0.59 centimeter. By converting it, we will get in this way 5.9 into 10 raised to minus 3 meter. And the diameter of the 5th ring, again in this way, it is a 3.36 into 10 raised to minus 3 meter. And see, P is the factor, means difference between these rings. 15th and minus 5 means 10. All these things we have been discussed in already in when we were discussing the Newton's ring method. In that lecture we have been discussed the things. Then radius of curvature, the radius of the plano-convex lens here is 100 centimeter. 100 centimeter means 1 meter, and therefore they are asking that we have to find out the lambda. See friends, we are having the formula for calculating the wavelength when we are using a Newton's ring experiment. Lambda equals to d square m plus p. M plus p is nothing but the number of rings minus d square m upon 4pr. This was the formula which we have discussed already in that lecture. And here d square m plus p is nothing but the 15, because p is 10, m plus p is 15 minus d square 5 upon 4pr. By putting the values in this formula in this way, by making the square of 5.9 and it is subtracted minus 3.36 square, and whole is multiplied by the factor 10 raised to minus 6 meter square, and 4 into 10 into 1. See, 4 is as it is, p is 10, and radius is 1 meter, and therefore by the square of this factor is this one, 34.81. Square of 3.36 is 11.28. All this is 4s are 10 is 40, and it is multiplied 1 means as it is. And see, by doing all those calculations, we get lambda, value of lambda is 5882 angstrom unit. This is the required answer of this problem. Now we will discuss about another problem which were asked in another examination. See, this is the problem. This concern with the Michelson's interferometer. In Michelson's interferometer, 200 fringes cross the field of view when movable mirror is moved through. This is nothing but a distance 0.0589 mm, and he is asking that the calculate the wavelength of light used. This was asked in April 2014. Now see what given things we will write here. D. What he is saying, movable mirror moved through this distance, that is a D, 0.0589 mm converted in meter, and m means the number of fringes that are 200, and we have to find out again the lambda. Then we know the formula for calculating the wavelength of source which are using in this Michelson's interferometer. That is nothing but lambda equals to 2d by m. This is the formula. And see now, 2 multiplied by d. D is the again this one, and divided by 200. By doing these calculations, we will get this much quantity, and it is nothing but the wavelength that light used is 5890 angstrom unit. This is the answer. Now we will see the another problem of a wedge shaped thin film. He says light of wavelength 6000 angstrom falls normally on a thin wedge shaped film of a refractive index 1.4, forming fringes that are 2 mm apart. Find the angle of wedge. We have to find out the wedge angle. This was the problem asked in March-April 2017. We will see what about this problem. See now, the given things we have to write here. Lambda they have been given, that is a 6000 angstrom unit. Mu refractive index 1.4 is given in the problem. See, the refractive index is 1.4 forming, this is a 1.4, and what is the beta? Beta is nothing but the fringe width, and it is a 2 mm. Now again we have to convert this factor. We will convert here in the by putting the values, and the formula for calculating fringe width is nothing but beta lambda 2 mu theta. See here, we in theory we have been taken 2 mu tan of theta, but the if angle is a smaller one, then we will take only theta, and therefore theta, for calculating the theta, lambda 2 mu beta, and by putting these values, lambda is 6000, 2 into 1.4 refractive index, then this factor 2 into 10 raised to minus 3 meter. This beta is converted into meter, and by which here the angle, that is theta, this fringe, this angle of wedge, this is nothing but the angle of wedge, and it is 1.07 into 10 raised to minus 4 radians. This is the required answer. And friends, you can solve these types of more and more problems for coming examination.